Okay, so welcome back. Let's do one more example. So we've got this one here, and so we've got n plus 1 over n. So notice something here again, just again, something you may or may not notice, but look at the top number versus the bottom number. So this thing is always going to be bigger than 1, right? So this thing, you're always going to be adding something bigger than 1 to the next term. Or how should I say this? So for each partial sum that you're going to have, then you're always going to be adding something bigger than 1 to it to get the next partial sum. Okay, that's what I'm trying to say. So I'm automatically thinking this thing is going to diverge, but let's determine that. Okay, so again, I'm going to write out the first few partial sums. So S1 equals what? 2. S2 is what? So let's see, 2. So 2 is going to be 3 halves. S3. Again, well, so you can see the pattern here. Oh, hold on a second. I'm getting ahead of myself. This is 2. So this is 2 plus 3 halves. Good, that's what I wanted. And then you're going to have 2 plus 3 halves plus what? 4/3. And then S sub 4 is going to be 2 plus 3 halves plus 4/3 plus 5/4. Okay? And then let's do one more. S sub 5 equals 2 plus 3 halves plus 4/3 plus 5/4 plus 6/5, right? Okay, now, again, let's go back to what I was saying. Notice that I'm adding something bigger than 1. But it's getting closer to 1, right? So each one of these terms, I'm adding something bigger than 1, but it's getting closer and closer to 1, right? 6/5, 7/6. So it's getting closer and closer to 1, but it's still bigger than 1. Okay, so I'm always going to be adding something bigger to 1. So I could say, well, this is equal to 2. This is bigger than what? It's going to be 2 plus plus 1. And this is bigger than what? 2 plus 1 plus 1. Right? 1 plus 1, so this would be 2 times 1. And this is going to be bigger than 2 plus what? 3 times 1. And this one would be bigger than 2 times, or 2 plus 4 times 1. Right? In fact, if I write S sub k, I could say that S sub k is going to be bigger than what? 2 plus what? K minus 1 times 1, which basically is just k minus 1, right? So this is just going to be for all positive k, right? For all k greater than 0. Okay, technically this would be equal to, but again, with exception to the first partial sum, this holds for all positive k. Integers positive k. So, what does this tell us? Well, just like before, this side is increasing without bound. Right? This is going 2, 3, 4, 5. This is increasing without bound. This is going to infinity. Okay, this sequence is going off to infinity. And this sequence of partial sums is bigger than that one. So this is also unbounded. And so therefore, the sequence of partial sums, right? So therefore, the sequence of S of k is divergent. And therefore, the series n equals 1 to infinity of n plus 1 over n is divergent. Or diverges. Okay. That's it. Have a great day.